Welcome. In this lesson, we're going to learn to find an angle measure from a triangle that has 2 or 3 sides given. We really only need 2 sides given if it's a right triangle, and we can use Pythagorean's theorem to find a third. But with the 2 sides given, hopefully you can think of these 2 special right triangles for many of these, because if you can do this without a calculator, by all means do so. But if you need to resort to a calculator, I'm going to teach you how to do that as well. But right here, I noticed that the ratio of this side to the hypotenuse is 1 to 2. Well, that ratio here, 1 to 2, is the 30-60 right triangle. So this angle measure R here is 60 degrees. The one up here would be 30 degrees. And then which one does it ask for? It asks for the measure of angle R. I'm going to just type in 60 degrees. By the way, make sure you remember your radian measure in case it asks for it in radians. 60 degrees is pi thirds in radians, 30 degrees is pi sixths in radians, and 45 degrees is pi fourths. But pi 6 is our answer, so I submit that. Okay, here again, a look at the ratio. If you need to go back and write down those special right triangles, please do so. But think of the ratio here. I have this 8 square roots of 5. Here's an 16 square roots of 5. It's just doubled. So again, if you double from the shortest side to the longest side, then it's just a 30-60 right triangle. This is going to be my 60-degree angle. This is going to be my 30-degree angle. And it's asking for the measure of angle S, so it's another 60-degree angle. Here, I got 9 square roots of 11, and now I got 9 square roots of 22. Think about the only difference is the number underneath the square root is twice as big. It's, in other words, I've multiplied going from here to here by the square root of 2. Well, that's the 45-degree angle. Measure of angle B is 45 degrees. Again, go back and write down those special triangles if you forget. I'm going to jump ahead. Again, this is 8 times the square root of 3 is 8 square roots of 3. This is a 30-60 right triangle. But eventually we get to some that will not be nice angles. Like this one here is not a nice angle. You'll actually use your calculator and your trig keys, and you're going to do the inverse. So because it says round to the nearest tenth, first thing I do, I'm going to find out which angle I'm looking for, angle H. That's this angle up here. How does the side that they give us, this side across here, that would be the opposite. This side would be the adjacent. So the tangent of whatever angle measure H is going to equal the ratio of 4 over 5, opposite over adjacent. Well, now how do I find the measure of angle H? Well, I use my calculator, that's supposed to be a big H, and I do the inverse tangent key, which is the second key and the tangent button. It'll have this little -1 that appears, and then you type in 4 divided by 5, and you just do that on your calculator, and you get your answer. Just make sure you're in the right mode as far as does it ask for it in degrees or radians. I don't remember. Oh, right here it has a degree symbol. So I'm going to make, my calculator's in degree mode. I'm going to hit shift or second inverse tangent of 4 divided by 5, and I get it's 38.659, and it says round to the nearest tenth, so 5 is 38.7. Type in 38.7. Now, the trig function you use will all depend on what angle you're looking at and what side you know. So for instance, I'm looking for angle K, opposite. Angle K is 5, 3 is adjacent, opposite over adjacent, that's tangent. So I'm going to do the inverse tangent of that ratio of 5 over 3. That was horribly drawn, but again, inverse tangent of 5 over 3, and I get 59 degrees, 59.03, but 59 degrees. Again, I'm using my inverse trig functions. Hopefully I'm going to run across, now here I won't be using the inverse tangent because I notice I have the hypotenuse, and then I have this side, which will either be the adjacent or the opposite depending on which angle R. So I'm looking at this angle here, angle R, that means this is the opposite side. This is the hypotenuse. Opposite over hypotenuse is sine. So I'm going to do the inverse sine of 4 over 6, or 2/3. Grab my calculator, inverse sine of 4 over 6, or 2/3, and I get my angle is 41.8. 41.8. If you have questions on how to do this, please do bring them to class. Just remember to watch in case it asks or it changes to radian measure, because I believe at some point it does change to radian measure, and you get to make sure your calculator is in radian mode in order to give the right angle measure. Well, so far they look like they're all degrees, but good luck.